Hello everyone and a warm welcome to the Directions Live Online by Esri Malaysia webinar. My name is Amir Faisal and I'm your host for today's session. Introducing today's presenter is Zatil Husna, a solution engineer from professional services at Esri Malaysia. As a member of the technical support team, Zatil delivers training to Esri Malaysia clients and helps resolve technical issues with the GIS platform. She had previously been an implementation analyst with Esri ISC in 2015 before joining Esri Malaysia. In this webinar, we shall learn on the workflows and custom 3D processing tools available to get started with 3D GIS. So we shall learn the out-of-the-box tools that will help you create, modify, and share 3D data from ArcGIS Pro, and discover the geoprocessing tools for generating I3S compliant 3D layers, custom solutions, and more. So without any further ado, I shall pass the presentation to Zatil. Over to you, Zatil.
Thank you, Amir. Good day, everyone. Thank you for joining today's webinar. And this time, I'm going to share something that's called creating and sharing 3D GIS data on the web. So I'm going to start off with the agenda of the webinar. So these are the things that we're going to cover today. First of all, I will do a bit of a review of what are GIS softwares from Esri that we could use to create 3D GIS data. And then we will talk about the processes of creating 3D content and three-dimensional GIS data in our ArcGIS desktop, specifically in ArcGIS Pro. And next, we will look at CT Engine, and we will also have a look on how to create 3D data using Drone2Map for ArcGIS. And in the second part of this presentation, I'm going to walk you through on a little bit about publishing 3D data to ArcGIS Online and Portal, which we will talk mainly about the I3S specification and scene layer packages. SLPK is one of the formats that is widely used in the GIS community for creating, sharing, hosting, and streaming 3D data on the web. And at the end of the session, I will touch a bit on ArcGIS Urban, a software that is designed to improve urban planning and decision-making. So we will start with 3D-enabled GIS software, and I will review of what product and software packages can actually be used to create 3D GIS data within the ArcGIS platform. First of all is ArcGIS Desktop, specifically ArcMap, which has been around for more than 20 years, I think. Basically, the software is not capable of creating and viewing 3D data, as it is actually a two-dimensional mapping tool. But however, ArcMap still have an extension that's called 3D Analyst. This extension provides an access to the traditional apps that are called ArcScene and ArcFlow. And with the presence of this extension within ArcGIS desktop platform, you can create, visualize, and analyze 3D data. 3D Analyst also provides you an access to analysis tools, which can calculate volumes to view shed analysis, skyline analysis, and view other things, and then display them in ArcScene as 3D data. And then ArcGIS Pro is released. It was initially released as an app that combined 3D and 2D in one app, so you can find all the capabilities of ArcMap or ArcScene and even ArcFlow in one app. One of the special capabilities of ArcGIS Pro is that you can switch from 2D to 3D at the click of a button. And next is Drone2Map. Drone2Map is an image processing software that can create outputs, point cloud, and integrated mesh as 3D dataset. And it can even publish them straight away to portal for ArcGIS or ArcGIS Online, which are capable of hosting and streaming that 3D data as hosted scene layer, which will then be consumed by desktop, mobile, or online client. And the last is the new software called ArcGIS Urban. We will talk about that a bit later. Before you can share some 3D data on your portal or ArcGIS Online, that data has to be created. So for this part, I will do a quick overview of some of the methods that can be used to create that 3D data. First of all, back in ArcMap in ArcGIS Desktop, you can use 3D data and visualize that in ArcScene, and sometimes that data can be something that is created in other software products like SketchUp, 3D Studio Marks, and etc. And that kind of 3D data can then be imported to Esri platform by using the Import 3D Files Geoprocessing tool. It can be converted into multi-patch data set. Multi-patch is the native format for storing and managing 3D data in a file data space, or it can be used for 3D symbology, for instance. And in ArcMap, you could also import KML or KMZ that store 3D geometries quite often in the form of embed collector file. DAE is the format extension, and that data can be converted into a layer using the KML to layer tool. And now in ArcGIS Pro, you can actually create 3D content by using just editing. You can draw a polygon extruded vertically, just grab some texture, maybe make a photograph of that building and attach that photograph to the side of the model created using editing tools. You could also use CT engine rule. If there is CT engine deployed somewhere in your organization, you can create rules and make rules packages and deploy them in ArcGIS Pro. And other than that, you could also use preset. ArcGIS Pro allows you to create preset. That's the picture on the right-hand side in the middle, in the slide here. If you have point data set, you can turn it into realistic 3D trees using one of the presets in Pro, or you can create a realistic building. You could also create 3D using extrusion or feature to 3D by attribute tools. This is type of geoprocessing tool that allows you to take a plane to the dataset, which might contain an attribute field that will store either height or depths and convert it into a true 3D feature class. So at this stage, I will jump to ArcGIS Pro, and I will show you a couple of methods for creating 3D content or 3D objects and features in our ArcGIS Pro. So now I will open a local scene in my ArcGIS Pro. It contains an elevation layer from ArcGIS Online, as you can see on the legend there. We are actually building multi-patches textured building from one of the training examples. So what I will do is I will go to Edit tab. I will click on Create, and I will click on 3D Building Multi-Patches, as this would be the layer that I'd like to create 3D geometry from. I'll proceed to draw the footprint approximately. Double click to finish, and then I can specify height, let's say 50 meters. And then once this is created, I can click on Save to accept the changes. And then next is I want to use multi-patch texturing tool, which is available under editing tool. I can go and pick up multi-patch texture, and what I need to do is just navigate to a folder which contains something JPEG, which I can then stick to the side of the building just by left clicking like that. And then once that looks good, I can apply the changes, and technically I can apply the same for the roof, but I want to use different texture for the roof here. So I just do the same thing. I go navigate to a folder containing the related image and stick to the side of the building. Okay, it's not changing over here. So I will just basically make sure that the building is selected, and I go back to the tool, select the multi-patch texture tool, and navigate to the folder that contains the image that I want to use for my roof. Okay, so that's about it. There is another method. So let me zoom out a bit. I have a bunch of building footprints that have been digitized. So we will use some CT engine rules to turn these building footprints onto 3D building. There is a processing tool in ArcGIS Pro. It's called Features from CT Engine Rules. If you have CT engine deployed in your organization, you can create a new package which you can apply to your 2D footprint. So, or you can actually grab one of the examples of a rule package from one of the Esri repositories website. So I just select one of the templates here, and then we can run the tool. It will basically convert each building footprint in an interactive texture 3D building and store the output as 3D multi-patch. Okay, now this building is generated randomly, and it is one of the demo rule sets that Esri provides. You could also create yours, which will generate the particular type of the building based on, let's say, the use type, the zoning type, or building type, or even any information that is stored in attribute table. So now, final step is I want to create some 3D trees using presets in ArcGIS Pro. So I have a bunch of points here to represent trees location, and I will select the realistic trees from the map tab, and I navigate to my feature class, 2D feature class that contain my trees location. And I will just select one of the models that are provided in the library. Okay. So now if I zoom in, I will see some real nice realistic palm trees in my area. So from there, that scene can be shared or exported, which I can go to the Share tab in ArcGIS Pro, and I can share that as a web scene and publish that to Portal or ArcGIS Online. Okay. So that's all the demo for this session. Okay, so now moving to Esri Local Government Solution. Within ArcGIS, there are several other tools that you can use to create 3D data. And while we are still staying in ArcGIS Pro, I will talk about some of the Esri Local Government Solution. There is a website where Esri publishes data models in tools that is called ArcGIS Local Solutions. One of these solution called 3D Base Map. There is actually a bunch of tools which you can download for free. You can use URL at the bottom of the slide, or you can just even Google local government 3D base map. Okay, and you can actually download and deploy in ArcGIS Pro. Basically, it's going to be an ArcGIS Pro project, which will contain tasks. Tasks are actually a kind of a predefined, pre-scripted workflows, somewhat similar to Model Builder. These are the recorded steps which you have to go through in order to achieve a particular result. And these tasks, they will preference the tools which you can just use by clicking next, and specifying parameters in the tools dialog rather than searching them all across the R toolbox. So these tasks will contain tools that will reference tools from 3D Analyst Extension toolset. You need 3D Analyst Extension to be able to run that. And basically, you will need LiDAR and building footprints, and then that solution can be deployed and open in ArcGIS Pro. And then you can extract 3D buildings, generate realistic roof shapes for this building, extract vegetation trees, etc., etc., and then in the end, publish web scene to Portal or ArcGIS Online. So there is another solution which you can find on the same web page. It's called with Shadow Impact Analysis. It's useful when, for instance, you would like to estimate impact of proposed development of building. So if you can create a model of the building and put it in a web scene, then you can use show impact analysis tools to predict shadows and how they will affect surrounding areas, building, the trees, etc., and publish that as web scene. Or maybe even to capture some feedback from the public, if you like. And staying within the desktop side of the ArcGIS platform, there is another tool, which is called CT Engine. That is actually the advanced 3D design modeling tool, and quite often it's used in conjunction with ArcGIS Pro and ArcGIS Online. So this is where you can use your existing 2D and 3D ArcGIS data, import models of building and whatever you like from other software packages like SketchUp models, from 3D Warehouse website, 3D Studio Max, and a few other formats that can be then inserted into 3D scene, where you can generate building that represents the existing buildings, and then you can model scenarios, say for proposed development, or for rezoning or redesigning of a particular area within a city. The method for creating 3D object or 3D geometries within CT Engine, they include basically drawing features manually, or the real power of a CT Engine is in dynamically creating these models using CGA, which was designed specifically for use in CT Engine that will generate geometries based on the script, in which you can use functions such as extrusion and assigning textures, generating roof of a particular type of kinds, and it will also contain a bunch of functions for reporting on the shapes that have been dynamically generated. Say you can report on things like gross floor area, floor to space ratio, and a few other things, which is useful in modeling and design. So you could use a dynamic scenario. So once that 3D scene has been created in CT Engine, it can be exported and published to Portal or ArcGIS Online. You can create a scene layer package, an I3S compliant scene layer package, or you can still use CT Engine web scene very quick and fast way, and it actually generate lightweight 3D scene, which can be just visualized through the web browser. And the data from CT Engine can be exported to third-party software, and quite often what people do is model the landscape, say model of a city, and then export it out to say an animation rendering software where you can use Maya or Pixel Random. If you want to see how CT Engine was used in animation, you can just Google Zootopia CT Engine, the famous Disney cartoon. CT Engine was used there to generate landscape, and they exported out the data into an animation rendering software where they completed the animation. And from CT Engine, you could also export your 3D GIS model data as Collada multi-patch and use it in our GIS Pro or Esri software. Okay. Next is Drone to Map. There is another software package from Esri, which is normally used for processing of imagery captured by drone. One of the outputs that the software is capable of producing is 3D outputs. You can create a 3D textured mesh, so the surface with all the features like building, trees, and cars. Geometries and textures combine into one continuous surface. It can be exported as an I3S on SLPK, which we will talk about them a bit later. It could also be exported as an OBJ, FBX, or DSF file and used, say, in CAD software. Drone to Map can also publish the data directly to portal for ArcGIS or ArcGIS Online. And now that brings us to the topic of sharing and publish three-dimensional data on the web. So what's inside of I3S scene layer? It's normally geometry attribute and texture combined into that mesh. Normally, it's an integrated mesh surface that includes vegetation, buildings, cars, or road, whatever you can find on the surface. If you generate your own I3S layer as a SLPK in ArcGIS Pro, you can just take the 3D model of a building and publish it as 3D object SLPK. It can actually contain points, and from recent version of ArcGIS Pro, you could also create points cloud SLPK and publish that. So in I3S, the I stands for index, so that's the entire idea of indexing. That's what makes that format very fast and efficient in streaming large amount of data. If you take the entire extent of the data set, it is split into region called nodes, where each of them gets the unique ID, and the software will, at any given time, when you display the vehicle or after, software will know which block or which nodes need to be retrieved. And as you zoom out or in towards the actual data that match the surface, it will keep loading more and more details of the initial node or route. Or as you zoom in, you will get more and more detailed picture. So now, in Esri platform, you could consume as SLPK that are created outside of Esri, as long as they are in compliance with the I3S specification. You could create them in CT Engine and also from Drone to Map. One of the important things that I need to mention is that this SLPK is currently non-editable. So once this SLPK is generated in Pro, you can only share and publish it. If you, let's say, want to clip a portion of SLPK of that mesh that contained within that SLPK, you will need to go back to the original data and do the clipping, for instance, and republish that SLPK. So the tools that you can use in ArcGIS Pro to generate this SLPK, they are shown in the middle of the screen and a slide there. There is package toolset, which was introduced a couple of versions ago. In ArcGIS Pro, you could use this tool to produce SLPK. Also, they can be automatically produced if you create a 3D scene, such as local scene in ArcGIS Pro, and you go create a web scene and go to Share tab and create web scene. If you have LiDAR data set, that will be published as point clouds in SLPK. And if you use this tool and you want to load that to portal or ArcGIS Online, you can do that using two methods. One of them is you can use the add item to web interface, but that only works for scene layer package that are below 1 GB in size. If it's greater than 1 GB, then you will need to use share package to processing tool. So in regards with sharing LiDAR data as SLPK, we can create that point cloud SLPK. There is tool for that in Pro. One thing I want to mention about the process is that it is very memory intensive. That means it has to be executed on the computer that has decent computational capabilities and enough memory. So once it is created, the data is compressed into SLPK, and you can then load it to Portal or GIS Online. So now at this stage, I will jump to my second demo. I will show you a couple of scene layer package published and presented currently as hosted web scene layer in GIS Online. So I will need to jump to my browser here. Before we could start with this demo, I'd like to mention a bit about the data set here. We are actually looking at Nadayu apartment, which is located in Banda Sunway, if I'm not mistaken. One of the Esri Malaysia teams is actually working on this, which I think they generate and process these data sets from drone to map and publish straight away to ArcGIS Online as scene layer. So as we're looking here, this data set contains approximately 2 kilobytes, and they are currently color coded by red, green, and blue RGB. Okay. So to navigate to some of the scenes, I will use bookmarks. So as I zoom in and out, it will load more or less detailed version of the data set. And so I will jump to different part of the area here, and it loads data very quickly, as you can see. So now moving next to another bookmark. This is actually the same hosted scene layer point cloud we saw earlier, but this is color coded by elevation. So you may go to Legend to see the range of the elevation here. And next is we're going to display this data set by class coded, where the points are symbolized based on the type of class, as we can see from the legend. Let me switch to that scene. So this is color coded by class code. You can see the class code from the legend here. So as we switch to display the scene in different bookmarks, the data set loads quickly, and we can just access the data using scene layer within the web app. Okay, so back to the slide. Working with integrated mesh data is actually is often supplied by vendors as SLPK. In most cases, they are ITBS compliant, so you can add them to ArcGIS Pro straight away and publish that to Portal or ArcGIS Online. Very often, they are created by the software called Context Capture, or sometimes Pix 4D Drone 2 Map. And from our observation, working with different types of data supplied by different vendors, we noticed that the mesh can be provided to clients into two formats, which is unique mesh format and tile-wise. Unique mesh is what we recommend to use as that is the optimized format. It loads faster, it displays quickly in web app, but slower to build. The other one, called tile-wise format, you will notice that this is the tile-wise format that the mesh was published. This way, when you load the data, it loads 5 tiles, one tile after one another. It's normally slower to display, but it's easier to create and take less time to create such an integrated mesh data set. And sometimes data can even be supplied as OBJ tiles, which are not georeferenced ones, and that will take a while for user to georeference the data. So some people will do that using FME. Some people just can go back to the vendor and ask to regenerate the mesh and send it as SLPK. And at this stage, I will jump to my last demo, which is working with an integrated mesh in ArcGIS Online. I'm going to need to go back to my browser. Okay. So I'm using the same data set as the previous demo, but this time they are in the form of integrated mesh. The size of this integrated mesh data set is nearly about 105 megabyte. That is currently hosted in our GIS Online. So I can jump in between the bookmarks, and you will see that the data looks pretty good, considering the fact that I'm actually connecting to the Wi-Fi. So as we keep on switching to another bookmarks, it loads quite fast, which is almost instantly. And we can just freely move within that surface. And zoom in closer. This dataset was actually shared as SLPK to our GIS Online. I then used the scene layer to publish as a web scene. And once it is published, I could add it to any web app. Say if I want to make my own custom web app using Web App Builder, or just use it as my own 3D based map in the scene. Okay, so that actually brings us to the last topic of my presentation. Going back to the slide. So ArcGIS Urban. ArcGIS Urban is basically a collection of web-based and desktop tools that you could use to create and manage an interactive 3D model of the city. You have managed plans, zoning projects. So if there is a proposed development, you can take a model of that proposed development, put it into 3D scene, and see what are the impacts will be. Or you can play with different scenarios. Say if we build a 10-story building, or what if we build fire starter building. We can have a look at the floor space usage and the others, report the other metrics. So with ArcGIS Urban, we can create 3D city model or base map. It is also an interactive planning tool within 3D environment. We could also create reporting on citywide performance indicators and capture feedback once this is published as web scene. And some of the features is going to be an ArcGIS Online based solution for now. And it will contain 3D base map, which you can create yourself or use some examples or even some model that are provided by Esri. There will be an interactive viewer, which you can just combine basic 3D representation and that 3D base map with other 3D scenes, such as you can create interactive 3D scene that will, let's say, provide reports or maybe average income or population statistics. And I think in this particular scene that they show in this 3D map in the slide here, they are actually reporting a number of accidents or incidents, some sort. So you could actually create 3D scene and include it to your ArcGIS Urban environment. So I guess that's everything for today's webinar. I will pass this over to Amir.
Thanks, Atil. There was an interesting presentation on the working with 3D GIS data. So we've had a couple of questions come through. If you have been listening intently to Zatil's presentation and you haven't had a chance to type out the questions, so there's still some time, so you can do this in the questions pane. So to just kick off, we have one question over here from Oswi Lin. The question goes, can this 3D explore this existing platform if one existing building that we import, can we view orientation of the sun? So I believe if I were to rephrase this question, it's talking about, can we explore the 3D scene where we can view the sun effect, for example, the shadows and stuff?
Okay, thank you for the question, Swilin. Well, my answer would be that if you would like to include your 3D objects on the scene layer of ArcGIS Online, you could actually do that. Because the sun, that is actually included under Analyze tool. There is one of the tools there which we can actually predict the sun orientation and what it can actually, how it can actually affect the shadows. Like, yeah, you could just play around with it to see that.
Yeah, just to add to that, so actually we have this function available in the scene viewer where you can simulate the sun, where you can start to see the shadows. You can start to pull a sort of a slider, for example, from 7 a.m. to the morning up until to the night, and you can start to see the how the shadow will actually appear in the 3D scene. So this gives you an example of the real life that you can see represented on the scene. So let's move on to the next question. This is one question from Muhammad Faiz. The question goes, is the 3D Analyst extension required for ArcGIS Pro to work with 3D maps and layouts?
Okay, so that is a great question, Faiz. My answer would be no. If you don't have this extension, you can still navigate, alter, edit, and share 3D maps, which are called scenes in ArcGIS Pro. So the ArcGIS 3D Analyst extension is only required for performing 3D analysis. So if, let's say, you want to run geoprocessing tools in the 3D Analyst toolbox, you will need the 3D Analyst extension.
Okay, that's great. So let's move on to the next question. We have one from Muhammad Arifin. So if I could rephrase this question, are there any other supported formats file that can be imported into Esri 3D engine? Can we accept external formats to be imported into 3D engine?
Okay, if you would like to include the external formats into 3D City engine, you will need to make sure that the data is in compliance with I3S specification, the one that we mentioned just now. So you can actually refer to the I3S specification to check whether you could actually import the data to our 3D City engine. And that actually depends on what format of your data is.
Okay, that's great. All right. So moving on to the next question, we have one from Richard Lee. The question goes, can I run models that I build in ArcGIS Pro in ArcMap?
Okay, thank you for the questions, Lee. In order for you to run models that is built in ArcGIS Pro in ArcMap, I think that it will not working as you can expect in how it actually works in ArcGIS Pro when it is in ArcMap. So my answer is that models that are built new or open and safe in ArcGIS Pro cannot be used directly in ArcMap. However, you can save the containing toolbox as a previous version and use that toolbox in ArcMap. It's safest to make a backup of the original toolbox before modifying any models in ArcGIS Pro. And you have to keep in mind that many tools and new data formats are only available in ArcGIS Pro. So the model still may not work in ArcMap.
Okay, so I guess here we need to stick to, let's say we have a model that's created in ArcGIS Pro, so it's best to stay in ArcGIS Pro. All right, so the next question is from Siti Anis. How does Urban differ from Esri City Engine? Do I still need City Engine if I'm using Urban?
Okay, Siti Anis, that is actually a great question. Well, Urban and City Engine have a lot of things in common. Example, they use the same procedural engine, but they also do differ in some ways. In City Engine, you could write custom CGA rules, whereas Urban provides a built-in rule that cannot be modified. What you can change in Urban are the parameters that drive the rule, such as the maximum height or the allowed floor area ratio. Well, one of the keys of ArcGIS Urban is that it is a web-based application, whereas City Engine is a desktop tool that is installed locally. So in general, Urban is a focused platform, not just a tool or web app. that supports urban planning workflows and facilitates communication between stakeholders. City Engine also supports the creation of detailed urban designs and produce sophisticated models of built-out scenarios.
Okay, so that's great. Let's move on to the next question over here. We have a question from Mustaza Mazuli. The question goes, I believe this is sort of like a repetition of the earlier question. Can we sort of like import stuff that we have created in a different platform and publish it to Esri platform? So I guess I think this is maybe related to the formats again.
Yeah. So you will need to check on the I3S specification whether the data that you're working on meets the requirement of that I3S. If it is, then yeah, you can actually import the data to one of the Esri platforms.
Okay. So the next question is from Kamaruddin. The question goes is ArcGIS Pro able to export these sort of format, 3ds and .obj?
3ds and .obj.
To export.
That one, I think I'm gonna need to check further on that. So I will need to get back to you with this question.
Okay, Kamaruddin, so we'll get back to you on this one. So Zati will check for you if we are able to export this one directly. Okay, so let's move on to the next question we have here. From Ahmad Afdal, can City Engine host 3D contents on the web?
Thanks for the question, Ahmad Afdal. Right? City Engine is not a web server and does not contain hosting capabilities. So you can, however, use City Engine to download content from ArcGIS Online and ArcGIS Enterprise and add it to your City Engine scene. You could also share City Engine web scenes to ArcGIS Online and in ArcGIS Enterprise in the City Engine web viewer and through the scene layer package files that can be consumed by scene viewer. Yeah.
Okay, so that's great. So that's all the time we have today. So if we have not answered your questions, Zati will surely reach out to you with a response. So moving on, just a little bit about what's coming next on our webinar series. So we have on the 24th of June, we'll take a look at the aspect of security within ArcGIS through the ArcGIS Security in the Cloud webinar. So this webinar will be led by Muhammad Akmal. So do keep a lookout for this space, esrimalaysia.com.my/webinars for any upcoming events and webinars. Thanks, Zatil, and thanks everyone for joining us. And we will see you next on the next Directions Live Online. Goodbye.